All right, let's continue with 9b, the second half. So you should have done up to the end of question 6 by now. So we're going to look at the angle associated with the gradient of a curve at a point. So we know that the gradient of the curve at a point is the gradient of the tangent at that point. So let's draw a line here. And imagine we've got a graph under here. This is our tangent and we want to know the gradient there. So we know that the gradient is rise over run. Always has been, always will be. So we also know if this was an angle theta, this would be the opposite and this would be the adjacent. And we know that the tan of theta is opposite over adjacent. Oh my God, that's amazing. So the tan of theta is the opposite over the adjacent. And that's where we come with this formula, m equals tan theta. So how good is that? Because if you understand it, you don't have to remember it. Of course the gradient is rise over run. We know that, it's easy. All right, so I've got some notation. If the gradient, f dash x, is greater than 0, we say the function is strictly increasing. Because the gradient is always positive. If the gradient is less than 0, negative, we say the gradient is strictly decreasing. It gets sort of a bit complicated and a bit technical, but if we think of something like a graph of x cubed, it looks like this. We know its derivative is 3x squared. So that tells me the gradient's always going to be positive because x squared is always going to be positive. However, when x is 0, the gradient is 0, but this is still considered strictly increasing. And that's where the strictly comes from. Strictly increasing basically means not decreasing. Strictly decreasing means not increasing. So 0 is actually included as strictly increasing, which I always feel like that's not that strict. Like if they're letting 0 in, how is that being strict? Anywho, the strictly is that it's not decreasing. So let's have a look at the sign of the derivative. So I've got a point here where x is b and the function is g of x. So this would be g of b. And this one here we've got a. So this would be f of a, and that's a really hard thing to get used to. Even when we don't know what the y coordinate is, we can put it in terms of our x coordinate. And if you learn to do that, you'll solve an awful lot of problems by doing that. Because if you had b and y, that brings extra variables in, but this means you've only got one, so that's actually really handy. So if we look here, we say when x is less than b, the gradient is positive. When x equals b, the gradient is 0. When x is between b and a, the gradient is negative. And then we get at a, the gradient is 0. And then after here, the gradient is positive. So for x greater than a, the derivative is positive. So with that, you should be able to do everything in 9b now. So good luck.